The question I have is, could you talk about field soil compactors? If you recall, in a previous video, we talked about these methods. These methods are good for densifying a cohesionless soil like sand. Here we will focus on a few other methods that are good for compacting a fill placed in a thin horizontal layer as part of constructing a highway pavement or an earth dam. So here's a little graphic depicting this process. I'm sure you've seen something like this along highways. Here's a fill material that was brought from a borough area. So what you do is, first you adjust its water content and then spread in thin layers called lifts like shown in this picture. Each layer is then compacted using a particular type of compactor like shown here. I'm going to talk more about this in the next slide. So the idea is to densify the soil in order to get a specified value of dry density. So these are some of the variables that govern the properties of the compacted soil. We have the thickness of the lift, which is usually between 6 to 18 inches. Then we have the type of compactor, number of passes, water content of the soil at compaction, and then of course it goes without saying, soil type, including gradation, maximum particle size, etc. I've listed a few examples of field compactors here: smooth wheel roller, pneumatic tired roller, sheep's foot roller, and tamping foot roller. So here are pictures of two of these. This is the smooth wheel roller, and you can see this part right here is pretty smooth. And this one over here is the sheep's foot roller, and you can see little protrusions here that look like feet. This table lists some of the key characteristics of these compactors. In terms of the coverage area, the smooth wheel roller offers full coverage. As you can see, the roller touches the soil through its entire width. The pneumatic tired roller still has a very large coverage area. Tamping foot roller is not too bad either. The sheep's foot roller has the smallest coverage area, which is obvious from this picture here. Only the feet are compacting the soil, and the total area of the feet amounts to just 8 to 12% of the area of the roller. To compensate for it, the applied pressure is very large here, 200 to 1000 psi, whereas here it's only 55, here it's only 100. This is basically the contact pressure between the contacting element and the soil. In terms of soil types, the first two can compact any type of soil. On the other hand, the sheep's foot roller is specifically good for clay soil, and the tamping foot roller is good for fine-grained soil, meaning soils containing silts and clays.